Next, we consider a randomized algorithm for finding a minimum cut in a graph. Likely, this won't be as familiar as quicksort. We're given a connected graph G, and the goal is to find a minimum set of edges whose removal from the graph causes the graph to have two connected components. This set of edges is called a minimum cut set. Note that this is a different problem from the minimum ST cuts that we considered in the context of maximum flow. There are no two particular vertices that we're trying to separate here. Any two will do, and all the edges have equal weight here. We can use the minimum ST cut algorithm to help solve the problem, but I think you'll agree that this randomized algorithm is quite a bit simpler. The algorithm proceeds by repeatedly contracting edges so as to join two together. And once there are only two vertices left, they define the partition. I'll illustrate with an example. Consider this graph, and suppose that we decide to contract this edge here. Then these two vertices are going to get collapsed into one, and we're going to delete this edge, like so. Note that we keep all the other edges in the graph, even if they end up being parallel, that is, between the same two vertices. From this graph, suppose that we choose this edge here. Then contracting this edge will delete this edge, as well as this parallel edge here, like so. From this group, suppose that we contract this edge, deleting these two here as well. Then the final result is this graph here. And from the result, we can read off both the partition, 1, 2, 3, 4 on one side, and 5 on the other. And we can also read off the cut set represented by the two remaining edges, just 3, 5, and 4, 5. That is, these two edges here in the original graph. Now, this particular choice of edges led to a minimum cut set, but not all such choices would have. How then should we pick an edge to contract? Well, it turns out that just picking a random edge is a good idea. More often than not, this won't yield a correct answer, but as we'll see, even so, it will yield a correct answer often enough to be useful.